Hi, this is Stephen Kingston here, and today I'm going to teach you how to simulate Newton's Cradle in SolidWorks. Go to File, New, and click on Assembly and click OK. Now I'll open up the different parts that you require in this assembly. The first one is going to be the mounting base. Place it in the workspace and then open up the mounting rod, keep it down, and then control drag to get another piece of it. And now start adding the required mates, a coincident mate for that and another coincident mate for that. Now let me just rotate this so that it's approximately placed in the correct place. Same thing here. And then I'm going to be adding some mates to fix these mounting rods in place. The same kind of mate for the other rod too. Now I'm going to add another mate here, which is going to be a distance mate, 60 millimeters there. Same mate on the other side too, 60 millimeters distance mate. And then this is still movable, so I'm going to fix it in place. Add another mate there, parallel mate. Oh, and actually that's a small mistake. It's not parallel, it should be coincident. Make that change now. Now add another mate, a distance mate for this end too. Just an approximate value. Some 220 will do for that. And then the next thing I'm going to bring in is the thread. Add a concentric mate with that hole, and then add a coincident mate so that it's fixed in place. Now you can see that the thread may not be exactly vertical, so I'll be adding a temporary parallel mate to make it vertical. I'll be deleting it soon after or suppressing it. And now I'd like 5 more threads, so just control and drag it to get a number of threads. And now I'll be adding concentric mates for each of these threads. Now I'm going to add coincident mates for all these ends. Now the next thing I'm going to add is the balls for the Newton's cradle. Concentric mates here too. Now I'm going to make the front plane of the ball to the threads right plane. Now I'm going to control drag to have 4 more balls. And now add concentric mates for each of those balls. So now I'm going to make all those balls exactly in line with each other. So I'll be adding multiple mates with the front plane of one ball and the front planes of all the other 4 balls. So they are exactly in line with each other. Now the next thing is I'll just take the first thread up a little bit so that I can start the simulation. So the mate that's stopping me from pulling the first thread up is the parallel mate there, so I'm just putting it into a temporary folder so that I'll be able to suppress it later so that I can proceed with the simulation. So now I'd want the ball to be in line with the first thread. So I'd like to add another mate there. Sorry, it's the front plane of the thread and the right plane of the ball. This is also a temporary mate. I'll be suppressing it. I'll just suppress that and take it up once again. So now we are ready for the simulation. Just click on motion study at the bottom and now select motion analysis, and now we'll be setting up contact between the 3 pairs of balls. Just remove the material, it saves simulation time, and under elastic properties select restitution coefficient and give a coefficient of 0.9, and under the selections give the first 2 balls. Do the same thing for the other 2 pairs of balls. No material and friction, and the coefficient of restitution is going to be 0.9. And now we can just run the simulation. I've just forgotten to add gravity. I'll just add it now, and the direction is along Y. Hit the check mark and now run the motion study. Now you can see that it runs. As you can see, the motion slows down as the time progresses. That's because the restitution coefficient is 0.9. Now in case the restitution coefficient is 1, you will have undamped oscillations. We'll just check that out a little later. Now I'm going to change the restitution coefficient to 1 in all of the 3 contacts. Now calculate the study, and now you can see that the oscillations are not damped. They always move with the same amplitude. So I think this gives a pretty good idea of how to simulate a Newton's cradle in SolidWorks. Thanks for watching.